Quick, graph y equals 5/2 times the sine of x minus 2 by hand. This is part of the family of functions series. You will need paper and straight edge, or you can download this PDF. Press pause as needed anytime. First thing we're going to want to do is analyze the parameters. So which parameters affect the y values? That would be 5/2 times and minus 2. The 5/2 times will multiply each y value by 5/2. Minus 2 subtracts 2 from each y value. And remember, by the order of operations, multiplication first, addition second. So let's look at the y values of the points of interest. We're going to multiply by 5/2 times the y value and then subtract 2. The maximum normally is at y equals 1. We're going to multiply that by 5/2 and subtract 2. And we'll get 5/2 minus, and we'll have to think of 2 as 4/2, which is 1/2. So the maximum now is at positive 1/2. Points of inflection are normally at y equals 0, but we're going to multiply that by 5/2 and get 0 and subtract 2 and get negative 2. Minimum is normally at y equals negative 1. We multiply that by 5/2 and subtract 2 and we get negative 5/2 minus 4/2, which is negative 9/2. Here's a quick summary of those and where we got them from. So which parameters affect the x values? And it turns out none of them do, which means the graph begins and ends at the normal points, 0 and 2 pi. So let's put all this together. We are going to need to change the units along the y-axis to take into consideration the max and min in the units. So we suggest y starting at -5 going up to positive 2 and marking off each half unit. Pause is needed. Resume when you're ready. And so this is what we chose this to look like. To help us plot the graph, we're going to draw dotted horizontal lines at the maximum, the points of inflection, and the minimum. So starting at the max, that's at y equals 1/2. So there's our horizontal line. The maximums will be plotted along that point, along that line rather. Points of inflection at y equals -2. And the minimum at y equals -4.5. So recall the graph of y equals sine of x. It starts off at a point of inflection at 0, 0. But in our case, it's going to be at 0, -2 because that's where the points of inflection are. The end of the period will normally at 2 pi 0. Ours is going to be at 2 pi -2 because that's where our points of inflection are as well. And halfway in between is another point inflection, normally at pi 0, but in our case it'll be pi -2. Halfway between these first 2 points of inflection is a maximum, normally at pi over 2, 1, but in our case it'll be pi over 2, 1/2. Again, this is halfway between these. So pi over 2, positive 1/2. And halfway between the last 2 points of inflection is a minimum, normally at pi over 2, -1, but in this, I'm sorry, 3 pi over 2, -1. And now it's going to be 3 pi over 2, -9/2 because that's the minimum value. Pause is needed. So we'll connect the points as a sine wave. So we'll go a frown concave down and then a smile concave up. We'll repeat another period to the left in the negative direction. So we'll start at that point of inflection, go back a period 2 pi. The max will go back 2 pi to the left. The next point of inflection and the minimum. Connect the points. And then let's look at it as a beautiful sine wave. Now you try one. Graph y equals 4 times the sine of x plus 1. You will need to change the unit Pause is needed. And so here we've listed the max, the point of inflection, and the minimum, plotted the points, and showed at least a little more than 2 periods.